Bismillahirrahmanirrahim. Assalamu alaikum dear students. I am Arif and I welcome you all in today's session. To access the notebook of today's session, you can access course page on my personal website Arif.me. You can click the appropriate link under this lecture resource column to view it in Jupyter NB Viewer and can run it on Binder online. The other way is to download it from the course GitHub account Arif and here is the public data science repository. Well, this is the Jupyter Notebook dashboard running locally on my machine at port 8888, and here is the notebook for lecture 2.13 of the second module, Basic Python Programming, for the course titled Tools and Techniques for Data Science. And here is the learning agenda of this notebook. My dear students, first of all, we are going to understand the difference between syntax errors and exceptions with example Python code snippets. Then we will understand the basics of exception handling using try except blocks. We will review some exception types in Python and the need of having multiple except blocks with one try block. We will also understand the need of else and finally clause in exception handling. And finally, we will close today's session by practically understanding the use of the raise and assert keyword. So let's start playing. So what are syntax errors? My dear students, syntax or parsing errors in Python are errors that are raised before the program actually starts its execution. For example, see this code snippet. Over here we have an extra parenthesis, an unmatched bracket, and once I will try to execute the code inside this cell, I will get something that is known as syntax error. Note that in case of a syntax error in this program code snippet, none of the statement is executed. This 1/0 is not executed. Let's see another example. Here is another example of syntax error with incorrect indentation. Note the first line is a division by zero statement which must cause an error, which must raise an error. Over here we have the indentation error. After the if statement, I have not indented this statement. Let me run this code. Once again, we have got a syntax error, indentation error. And once again, remember, this indentation error has occurred at line number 5. So this proves that in case of a syntax error, none of the lines gets executed and your code is evaluated for the syntax error, and this is done by the Python interpreter. Okay, so what are exceptions now? My dear students, an exception is an error that happens during the execution of a syntactically correct program. So this cell contains a single statement, syntactically correct, and it is causing a division by zero error. And this is going to disrupt the normal flow of program execution. And whenever this line will execute, whenever the Python interpreter will execute this line, Python will generate an appropriate exception object. And that exception object over here in this case is a zero division error that represents this error. So this is an exception. Let's see another example. Over here I have a list containing 3 elements at indices 0, 1 and 2, and let's suppose I want to access an element at index 8. So of course this will again cause an error, and that will be an exception that will be caused only when this line will execute, and the error type is index error. Let's suppose we have written this program. This program actually prompts the user to enter temperature in Fahrenheit. It typecasts it to float, saves it in this variable FAR, and then use this expression to convert that Fahrenheit temperature into Celsius, and then finally prints that Celsius. Let me run it, and let me say 32. So of course 32 degree Fahrenheit equals to 0 Celsius, and let me say 100, and 100 degree Fahrenheit equals to 37.77. The program seems to be working perfectly fine. Let's suppose I run it and the user entered, instead of a number, he or she just entered a string. Let's see what happens. So this is again an exception, and the exception is value error. Actually, this exception has been raised because we have got a string over here and we are going to typecast a string using the typecast operator of float. So it has raised an error. So I hope you have a fair idea now what exception is. Now the next question is how to handle exceptions. My dear students, I have tried to explain this in this image. Whatever piece of code that you have written and you expect that for whatever reasons it may raise an exception, you put it inside a block that is known as the try block. So you write down the try keyword followed by a colon, then an indentation, and you write down your code. And after that code, you have an except block. You write down the except keyword and then indented code. And this is the code which will be executed whenever an exception will be raised inside the try block. Okay, so let's see this with an example. The same example. So the same program in which I am getting input from the user, I have placed it inside the try block, and this is the except block, the single line of except block. If an error will be raised over here, this except block will be executed. And let me say something here again. Great going. Okay, so let me run it. Let me say 100. So the program executes perfectly fine. This except block, the code inside the except block is not executed. Let me run it again and let me give a string this time, and you see this time the error has been raised on this line. The control is transferred to the except block. This line is executed and the program continues its execution. That is, the program has not terminated abruptly. So this is what exception handling is. Very simple. You place the code inside the try block and you write down the code to handle the exception just in case if it is raised, and place it in the except block. And the code inside the except block is executed only if there is an exception that is raised inside the try block. Otherwise the control will move ahead of the except block. And this is what we have seen over here. I hope it is clear. Let's see another example. Over here, let's see this. This is the try block, and in this try block we have 3 errors. The first error is the division by 0 error. So once I will execute this, this line will raise an error or exception, division by 0 exception. These two lines will not be executed and the control will come up over here. And it will say simply an error has occurred. Let me comment this, or let me say okay. So now let me run it again. Now once I will run it, this variable z actually doesn't exist and the error will be raised and it will just say an error occurred. Let me put a comment over here and let me execute this now. And this execution is actually trying to concatenate a number with a string, and the plus operator cannot do that, so an error will be raised again, and it will simply say an error occurred. So this is good, simple. This except block is catching all sort of exceptions. However, it is not helping the programmer to identify the root cause of the exception or error. It is just printing a simple message, an error occurred. Uh, just consider or visualize that this is a huge piece of code. There are multiple files in which this code is spread, and then you get a message. So it is really difficult to identify the root cause of the error. My dear students, there are different types of exceptions. There are several built-in exceptions like a zero division error. So this exception is raised when you perform a division by zero. A value error. This is raised whenever an argument that has the right type but an inappropriate value is passed to a function. So this is an index error we have seen above, is raised when you try to refer a sequence which is out of range. End of file error. You come across this end of file error whenever the input function hits the end of file condition without reading any data, and so on. So my dear students, whenever an exception is raised, an appropriate exception object is created of any one of these class, and it is sent to the except class. Let's see this over here. This is the try block having these again same 3 lines of code, and this time over here after the except I am receiving the argument. I'm receiving the argument, I'm receiving the object of the exception class that is raised over here. I'm receiving that over here in this variable e. And instead of just saying or printing that an error has occurred, I am saying exception occurred, and then I am writing the name of that object. So let me run it. And you say, since this line has caused an error, so the error is division by zero. Let me comment this and let me run it again. Now this time this line has raised an error, and it says name z is not defined. This is the error. Let me comment this line and let me run it again, and you see the error is now saying that unsupported operand types for this plus operator, an integer and a string. I hope this makes sense. Okay, so over here you have seen that in this piece of code there are 3 different types of exceptions that are raised, but I am receiving all those exception objects in one except clause and doing something over here. What if I want to that I should do something else when a division by zero error has occurred? I should do something else when a variable is used which is not defined, and I should do something else when this operand are not supported by the plus operator. So I want to perform different actions in case of different exceptions. So one of the solution to this is that I can have multiple except blocks over here instead of having one except block. And this is what is shown over here. More or less the same piece of code. And I am having multiple except clauses. And you will see once I will do a division by zero, it will be handled by this except clause. It will say a zero division error has occurred. And let's suppose, let me say this, this time, okay. Import Kakamana. So I am trying to import a module which actually do not exist. So when this exception will be raised, it will not be caught by this, by this, by this, by this. Rather, it will be caught by this module not found error. So great. So this is what we can use in case of this. Remember, in Python there is no concept of default catch block. And one more thing, that only one of the except block code will be executed. Whenever the first exception will be raised, the corresponding except block will be executed and the code will move ahead. Okay, now let's uh, see the use of the else and the finally clause inside the try catch or try except. My dear students, in case of okay, in case of you want that whenever this try code has executed and no exception has been raised, some piece of code should be executed. So that code is placed inside the else clause. Let me repeat again. Once you use an else clause with the try except, the code inside the else block will be executed only if no exception is raised. And in case if some exception is raised, then this code will never get executed. And as far as this finally is concerned, we place that piece of code over here which we want that should always run. Whether an exception is raised above or an exception is not raised, the code over here should always execute. Then you should place it in finally. And normally we put the normal cleanup codes over here. So let's see an example of else clause first. So over here you see this is list 159 and it says list elements are this. So if I run it something like this, no error will be raised. So this will execute. This else class will execute because no error has been raised. And let me do something like this and let me execute it. Now a division by zero error has been raised. This except clause gets executed. Zero division occurred and handled. And of course, since an exception has been raised, the else clause has not been executed. And this is what I said over here. In case you have an else block associated with the try except, this portion will only execute if no exception has been executed. And one more thing, remember, if you have multiple except blocks like we have here, you must place the else block at the end. Okay, let's move on to the finally clause. Well, this finally clause is used to execute piece of code that must execute whether over here an exception has been raised or an exception has not been raised. Important thing to keep in mind is this finally block must be placed after all except blocks as well as after the else block. And the code over here is normally used for cleanup actions. So right now there is no error, no exception will be raised in this piece of code. So this finally portion has been executed and now I have mentioned an exception over here. This will be raised. The else code will not execute, but the finally code will execute. Great. I hope this makes sense. Okay, my dear students, before I close, let me talk about two more keywords. The first is the raise keyword. The raise keyword is used to raise an exception in Python. For example, consider this example. Suppose I need to get age from the user, and if the age contains something negative, I need to raise an exception. And to raise an exception, I use the raise keyword. Over here, let me comment this line and let me do this. Now age equals 5. So age is less than 0. This will be false. So this line will not get executed. This line will be executed. Make sense? Let me change this now. Let me make the age negative. Now age is less than 0. Yes, age is less than 0. This is true. So this line will be executed. So this raise will raise an exception and will pass this string to that object and it will print the appropriate message. So the exception will be raised. An appropriate message over here is in front of you. The program has terminated and this message is there. X should not be negative. The value of age was -1. Let's see another example. Okay, so over here we have a variable X containing a string hello. and I'm saying if not type of x is int. So right now type of x is hello, which is not an int. So this condition is true. So this line will be executed, and this raise keyword or raise statement will raise this error. Over here I have raised a general error of exception class, and over here I have raised a specific error, type error, and I have given a message over here as well. So you see the special message has been printed, type error, and this raise is basically just to raise an error on if on a situation if a condition is true. But over here you have noted one thing, that whenever the condition evaluates to true, this raise statement is executed and our program crashes midway. So with this, let's move on to the assert keyword. So instead of waiting for our program to crash midway, at times we need to check out certain things in the very beginning of the program. We check certain conditions using the assert statement. And this is the assert statement. You give a condition to the assert statement, and if this condition evaluates to true, the program continues. And if this evaluates to false, this line will be printed. Let me say again, this is a bit tricky. This is the expression, and if this expression is false, only then an exception will be raised, and the exception type is assertion error. So over here we have the if clause, and then we are raising exception of our own choice, and over here we have simply one statement which is evaluating an expression, and if this expression is false, this happens. So let me make the age negative and see how it behaves. So it raises the assertion error. Let's see this example. So this x contains a string, and I say if the type is an int, so then the exception should be raised when this condition will evaluate to false. So right now x contains a string, which is of course not an int. This condition is false, therefore exception has been raised, and the exception type is always assertion error in this case. Let me comment this x and let me do this. No exception will be raised. Actually, assert is used in these situations. Over here I'm just checking out in the very beginning of the program the platform on which this program is going to execute. And I am just importing the sys module, and this sys.platform actually returns a string mentioning which is the platform on which you are working. Let me run it over here again. Import sys, and let me simply print this string platform. So for a Mac machine it will say Darwin, and if you are a Windows user it will say Windows, so Win32 or maybe Win64. So over here, since I'm using the Mac, so I am checking this assert statement. So if this is in this, if this condition is true, only then we will move ahead, and if this is false, the assert will raise the assert error. And let me do something like this. Now since my machine is Darwin, so this will return Darwin. It doesn't match Win32, so this will raise an exception, and it will say that this code runs only on Windows. Okay, so my dear students, do try answering these questions to check your concepts. Do understand the difference between checked and unchecked exceptions, and dig out the details regarding the use of user-defined exceptions in Python as well. And for that, you can always visit this link of Python documentation. So that is it, my dear students. I hope this session was informative for you all. If you have liked it, please subscribe my YouTube channel and share it with your friends. I wish you all the best. Happy learning and Allah Hafiz.